In this video, we'll be talking about a new method of declaring the winner of an election, the pairwise method, sometimes called Copeland's method. So the truth is we already kind of know how to do this method because it's the basis of the Condorcet criterion, but nonetheless, let's see how it works out. So what I have here is the results of a new election. So again, there's 4 candidates now, A, B, C, and D, and we've asked all these, there's going to be 40 voters. We've asked them to come out and rank their candidates first through fourth, and we have the table of data here. So now how this method works is pretty simple. It's called the pairwise method because we make all the possible pairs of candidates. So we have AB, AC, AD, then we have BC, BD, then we have CD. So this is all the possible pairings. And just like in the Condorcet criterion, we pit them against each other and we see what the score is, and then we declare a winner on each case. So let's just first calculate the score of the first 3 just to get a feel for how it's done, and then I'll just list the other 3. So A versus B, who's going to be the winner? Well, who gets these 10 votes? A gets these 10 votes. A does not get these votes. A gets these 9 votes, and then A loses these other votes. So A has 19 votes total. So the score is 19-2, and we can calculate B, but since we know there's 40 voters, this is going to have to be 21. So it's 19-21. Who's the winner in this case? It's going to be B in this case. So now, A and C, who's going to be the winner? We have 10 votes here. A gets, what other votes? He gets these 5, he gets 15, and that's all he gets. So he gets 15, and this is going to be, again, 40 voters, so this is going to have to be 25. So who's the winner in this case? It's going to be C. Now, A versus D, who's going to get these votes? So A gets these 10, he loses these, he gets these 9, so he has 19, and he loses this, and he loses this. So he has 19. Again, versus 21. So who's the winner here? It's going to be D. And we just kind of continue, we continue in that fashion, and then we see, all right, on the other ones, it's going to be 27-13, and who's going to win that? It's going to be B. Then it's going to be 22-18, and who's going to win that? It's going to be B. And then we have whopping 35-5. Who's going to win that? It's going to be C. So now what do we do with this data? Now notice in each case we have a winner. The winner will be awarded 1 point in each case, and the loser is awarded 0 points. So this between A and B, B won. So B gets +1. And C gets +1 here. D gets +1. So all these winners we see here, they get +1. And then if you guessed it, all we have to do is just tally up how many points each person has. So we're going to do A, B, C, D. How many does A have? Unfortunately, he didn't win any of his pairwise competitions, so he's going to get 0 points. B has 1, 2, 3 points. C has how many points? C has 1, 2. D gets that 1 point. Now, how to make sure you did this correctly? One good check is to add up all these numbers, and we get 3, 4, 5, 6, which makes sense because there was 1, 2, 3, 4, 5, 6 comparisons. So this number should always add up to this number. So now a little thing to talk about. If there's ever a tie, I created this example so there can't be ties, so there's no way to get 20-20. There's no way to capture that range of votes. But if there is a tie, which we'll see in the next example, then you give each person half a point. So if there was a tie between A and B, if it was 20-20, A would get half and B would get half. But the thing is that these half and half still add up to 1. So at the end, when you add up all these, they should still add up to 6 total. So the winner here under the pairwise or Copeland's method is going to be B. Now, here's something interesting. Who would win under the plurality method? The method we said was pretty bad. Under this plurality method, A has 10 first place votes, B has 12, C has 13, and D has 5. So C with 13 first place votes would win. So under plurality method. But we talked about how plurality method is pretty bad. But here, what I've done here, I'm going to uncover this. I've written the board accounts for each candidate. So for A, B, C, and D. And we see that the weird thing is under Borda method, we have C gets 113, which is more than 110. So under the Borda method, C would be the winner of our election, just like under the plurality method. So these methods can disagree, and we'll do a more extreme case of this in a later video. But just important to note that under the pairwise method, the winner was B, but under the Borda method, the winner is C. Okay, so now next thing to talk about is how many comparisons do you have to make? In this case, we had 6, but if we had let's say 5 competitors, then it would have to do 10 comparisons. So how do we know how many comparisons to do? Well, it's easy if we just look at a little pattern. So in this case, we had 4 competitors or candidates. We had A, B, C, and D. And what did I do first? I wrote down A versus B, A versus C, A versus D. That's like one block because it's all listing A first. So A has to be listed against all of the other candidates. And how many is that? That's going to be, if we have, let's say, N candidates, then this first block is going to be how big? It's going to be N minus 1 because it's going to be the first candidate versus all these N minus 1 candidates. Okay, now how big is the second block? First, let's identify the second block. The second block starts with B, so BC and BD. This is the second block, and how big is that going to be? It's going to be one less because we've already taken care of one of these, AB, so we don't have to write BA again. So we have to do n minus 2. And now how big is this last block? It's just the size of CD, so it's going to be, again, one smaller, so it's going to be n minus 3. So this n in this case was what? This n in this case was 4, so it's going to be 3 plus 2 plus 1 equals 6, just as we see. But in general, you're going to have n minus 1 plus n minus 2 plus n minus 3 plus dot 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 plus until the last one, which is 1. And if you remember your Gaussian sum formula, just the sum of the first n minus 1 integers, or go refresh yourself on that, that's the sum is going to be n minus 1 times n over 2. And that's how many comparisons you're going to have to make. So if you plug in however many competitors you have, for example, let's plug in if we have 5 instead of 4 people. So 5 minus 1 is going to be 4, and then times n, which is 5, divided by 2. So 5 times 4 is 20, divided by 2 is 10. So the next example, which has 5 competitors, we'll see we have to do 10. So this is just a good way to look at it. If this number is small, if the number of comparisons is small, you can probably do it by hand, maybe up to like 15 or something like that. But if it gets big, you either want to use a different method, or if you have a computer that you can program with this method, that's even better. Then this number can get pretty big. So that's just important to know. It does get a lot of comparisons as you get more and more candidates. Okay, so the next thing, as we've talked about in every video, we need to talk about issues with this method. And how we're going to talk about issues is just with an example. So here I have the data for another election. This one has 5 candidates, as promised. And there are a range of 7 different different ways of voting. So these 3 people voted this way, these 7 people this way, and so on. So usually we don't have this many, but it's going to be important in this case. So we have 7 different types of voting, how people rank their candidates. So now let's just look at the pairwise method and see what happens. So I have all the data already because we don't want to do the nightmare of going through all of these, but we'll see. So we have A versus B, who's the winner? B. A versus C, A. And then we have all of these. Notice that BD and CE, these 2 competitions, are ties, which means that in the BD case, B gets half, D gets half. In this case right here, C gets a half a point, E gets half a point. So now let's tabulate who has most points. So B has how many points? He has 1 half, so that's 1.5, 2.5, and that's it. So he has 2.5 points after all of this. Okay, how many points does A have? He has 1, 2, 3, and that's it. So he has 3 points. C has how many points? He has 1, 2, and then he has 2.5. So C has 2.5, and then so D has how many points? D has 1, and a tie here, so 1.5. And E has how many points? So E doesn't appear anywhere here except here, so he has 0.5 points. So now if we add all of these up, so this is corresponding to D, this is corresponding to E. If we add all of these up, they should add up to 10, right? Because we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 competitions. So 2.5 and 3 is 5.5. Then we add this, that's going to be 8. That's going to be 9.5 plus 0.5 is 10. So good, that's a good check. We're done. So now who's the winner? A, with his 3 points, is declared the winner here, right? Under the pairwise method. Now let's see something weird happens. Let's say instead of this happening, C were to drop out of the race. So C is like disqualified, or he drops out for some other reasons, personal reasons, whatever. So what does our intuition tell us? Our intuition says that since C was not the winner of the election when we calculated him with him in the election, if he drops out of the election, then the winner shouldn't change. A should still be the winner, right? Think of it as if you're running against 5 people and you win the election and somebody else does not, then it doesn't matter if they were in the election or not. If they weren't in the election, you would still win, right? That makes sense. Well, that does not hold true for the pairwise method, and let's see why. So let's look at this new table right here with C taken out. So with C taken out, there's only 4 competitors. So it's like the previous case we did with 6 competitions. 1, 2, 3, 4, 5, 6. Okay, so you don't see C here. Now A versus B, who would win? The neat thing is that we can just pull that data right off this table because the relative order of people in this table doesn't change when we cross out all the C's. So A versus B, again, this competition, B would win. A versus D, we would have A would win. A versus E, we would have A would win. B versus D, we would have a tie. B versus E, we would have B would win. And D versus E, we would have D would win. Okay, so now let's see who would win. So we will tabulate everyone's points we have A, B, D, and E. How many points does A have? He has 2 now. What happened to his last point? Well, what happened is that somebody that he won against dropped out, so he loses that point. So we see where this is going, kind of. How many points does B have? B has 1, 2, plus the tie, so he has 2.5. Uh-oh, so that's interesting. So D has how many points? D has 1 and a tie, so 1.5. And E has how many points? Well, E actually lost his only half point because the person he got it against is gone. So let's do our quick check. Does these numbers add up to 6? 2, 4.5, and 1.5 is 6. Good. So we checked that. So now who won the election? A lost because he only has 2 points. B has 2.5 points. So something weird just happened. These voting methods can get pretty weird. Just like in the previous video, we saw how the weird thing that happened was getting more points causes you to lose. In this case, the weird thing that happened was someone dropping out that wasn't even the winner caused the new winner to change. That's pretty weird. So to capture this weirdness, we're going to look at this new criterion. So this is called the Independence of Irrelevant Alternatives criterion. Short form is IIA. So Independence of Irrelevant Alternatives. And that's just a fancy way of saying that if X candidate wins the election, and if you do a recount, and the only change is that a non-winner drops out, X should still win the election. And that to our gut, that makes sense. But it's not true in the pairwise method case. So we're going to say that the pairwise method, it violates this. Just as we said that certain methods before violated different criteria. So this method is not without its shortcomings. This issue does arise. It does violate this. So let's just look at an overall view of this method. So the things that it does satisfy, it satisfies the majority criterion, which means that if someone has more than 50% of the votes, this method will declare them the winner. It satisfies Condorcet, not very surprisingly because it's kind of based off Condorcet. Satisfies monotonicity, so which means that the problem with the previous video was that when someone gets more votes, they somehow lost. That's not going to be a problem here, but it does violate IIA, which is kind of a big violation in itself. Also, it often causes ties, which you can see because unlike the board account method where we had huge numbers that aren't going to be, there's not a big chance that the numbers are going to be equal. Like when you have the numbers in the 90s and the hundreds, it's a pretty small chance they're going to be equal. In this method, the numbers are small, like 2 and 2.5, 1.5. It's pretty easy to get something to land in the same number. And then when you have a tie, then you kind of have to use a new method or figure out how to let the tie stand or something like that. So it is a really good method because it satisfies all of these, which is something we cannot say about any of our previous methods. But it is important to note that it violates a new criterion, the IIA, and it also causes ties pretty often. So you might have to resort to an older method in the end. So this is all of our methods that we talked about. So next thing we'll talk about is how to use each method to rank, how to get a first, second, third, and fourth place. We'll talk about recursion, and we'll talk about, is there a method that can satisfy all 4 of these criterion?